All right, here we go. Yay. Welcome again to Astronomy Daily Live. It's 2 hours UTC. And, well, come on in, everybody. Come on in. Join the ever growing circle of friends as we gather together practically every day. At least we try to get together every single day to, share a common passion. Uh, Mainly astronomy, but in a broader sense, science, life in general. It's all pretty amazing, pretty mind blowing, and there's always a surprise, and there's always something new, right? I mean, that's one of the things that being an astronomer. And wow, it's actually kind of warm. You know, Pretty amazing. Being in the southeast or southwestern deserts here. Um, Yesterday it was rainy and cold, and just sort of like life on a different planet, right? And today it was bright blue skies, sunny, and hot. It was actually it probably got into the 80s here, which this time of year is a little warm. It's a little warm. So yeah, just absolutely amazing. But yeah, so come on in, everybody. Welcome. I'm gonna pop open my chat here to make sure. Hey there, Tom. Nice to see you in the chat. And on the panel is Bobby. Hey, what's going on?
And the man said, Tom, why you're not here? Oh, too many distractions.
Distractions.
Too many freaking shenanigans. Oh my gosh.
Yep,
I
shenanigans.
I didn't feel like joining the panel, but I don't want to let cosmic strangling here. We're trying to find out what's going on in the chat and doing this stuff at the same time.
Yeah, cool. Yeah. You don't want what do I say? Um, you know, anything that can be used against you or anything. So yeah. If you've got some distractions there, yeah, feel free to be completely distracted. Yeah. So, but yeah, glad those of you who are here are here, and yeah, I think this is a pretty amazing thing, and okay, shenanigans, yeah, um, and yeah, we're just gonna keep doing this and doing it because it's just fun, right? I mean, for me, this is definitely not work or anything that is like, oh man, I got to do this again. No. I mean, this is easy. This is something that I would sort of normally, naturally do. The only thing that I'm sort of doing different is sort of talking out loud. But otherwise, I would be pretty much you know be doing exactly the same thing I'm doing now. So yeah. So why not share it, right? Why not spread that passion around and see where it all goes? And what I'm seeing is that this live stream is unique and different. Maybe not for everybody, but I'm not necessarily trying to cast this wide net, right? I'm trying to be more like a harpooner, who it's like, there's one, bam, gotcha. And so far, what I've observed in this ever growing community is some pretty some pretty amazing people who are yeah, just absolutely incredible. And you know, they are here regularly, and I think that's absolutely awesome. It's absolutely great, and I think, you know, over time, this kind of format, you know, this kind of a format for science, right? That is supposed to be, you know, very formal and very serious, and you know, trying to teach us things, and you know, I've mentioned this many times, where it's sort of like, you know, the scientists have taken over the role as sort of the high priests, right? When there are questions that need answers, right? We go to the scientists who claim to have sort of a handle on all these things, and I mean, that's okay. I'm just trying to put that, you know, into a little bit of perspective, that you know, yeah, you know, science is a pretty amazing thing, right? I mean, we we have definitely stumbled upon something that seems to work really well. Um, but it's so easy, you know, for all of us, you know, to sort of fall into these ways of thinking, and you know, you can call them dogmas or beliefs or whatever you want, but you know, we all exist in some kind of a box, um, and you know, sometimes the box is a little big, and sometimes the boxes are a little bit small. But the fact of the matter is, at least it's been my observation, that we all live in sort of this box, and you can't. Well, it's really hard to see outside of that box. Um, and but as a scientist, that's sort of what you have to do. It's like, okay, you know, here's the box we're in. Now, you know, is there anything outside of this box? And if there is, what is it? And how do I access it? So yeah, you know, so like I was saying, I think, you know, this kind of a format, live stream, a little bit more casual, a little bit more, uh, um, you know, just sort of relaxed and fun, and
Thank God, that freaking cat.
full of kitties. Yeah, I think, you know, that that sort of presents a different face on science, and specifically, you know, the science of astronomy, where like I say, you know, we're sort of perceived as you know, very serious, and you know, I think we know a lot and all of that, and you know, being an astronomer, I am here to say that yeah, you know, there are times, I guess, to be serious, but for the most part, it's you know, it's sort of mostly about just following a passion, having fun, and you know, following your
I
bliss.
should know if that cat is ever going to knock down that webcam of yours.
Well, I don't think so. It's way up here, and um, there's look, there's always
The way you pointed that finger, it's almost like, dude, I would need some 3D glasses.
right there.
Oh, dang, my eyes.
Yeah, I'm poking in the eye. Look at that. It went out of focus. So look, you're gonna have to look at my dirty hand for a second here, and then whammo. There it goes. Cool. Cool. So Todderbert, nice to see you in the chat. Uncle Bill, nice to also see you in the chat.
Welcome.
Hope everybody's doing well out there. You know, without distractions. There's always distractions. Yeah, always. So I've got the hydrogen hydroxide here again, HOH, and I've got, you know, I gotta say, I've got at least 10 to the 24th molecules here, at least. So yeah, that's a couple. So here, I'm just going to move them a little bit. Hold on. Or I moved a few quadrillion. Yeah. All right. Well, cool. So let's see. I guess I wanted to start tonight. Well, one, my apologies for missing the live stream last night. We I guess what happened was that all this rain that we got 2 days ago and yesterday sort of worked its way into various wires and was causing the internet here to be either well, somewhere between very, 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 very slow or non-existent at all. C2H5OH, you know, we would definitely need to do some kind of an analysis on this to be absolutely sure, but my guess is that there probably is a little bit of that, but an extremely insignificant amount. So it's probably there, but it may not even be measurable. Maybe not. But I don't have the means of doing that kind of analysis, so you're just going to have to, you know, keep guessing. But yeah, so yeah, and I understand. No apology is necessary, but yeah, you know, it's kind of a bummer. You know, I mean, I totally understand that you know, when I'm
that's right.
yeah, when I'm looking forward to things, and you know, they don't happen. It's sort of a bummer and stuff. I think I'm going to. I think I'm being summoned over here. So let me let me take care of this first, really quick. Hold on. All right. Now I'll get paid. I've earned my pay. Phew. I've been waiting all day to be able to do that. Finally. Phew. I always worry, you know, if I'm going to be able to do that or not, because that is what I'm paid by. So, you know, the times, the number of times I open doors to the masters around here. So, all right, well, cool. I think what I wanted to do first was, yeah, vapors, was go over and take a look at asteroid Bennu that is being approached by the OSIRIS-REx spacecraft. And I think what I wanted to do was actually go and just sort of take a look at sort of the highlights of the OSIRIS-REx mission. Yeah, I'm especially interested in knowing when the rendezvous date is, because I think it's coming up here really soon. I mean, within the next, I don't know, month or something like that. So yeah, I wanted to check that out. But I noticed, I think this was on I want to say this was on Twitter. This image that they posted. So I'm going to share my screen here. And let's go over to here. So here they're showing an image of Bennu, which is the asteroid that OSIRIS-REx is moving towards, and an image of Jupiter that was taken when OSIRIS-REx flew by Jupiter. I don't remember when that was. It was a while ago. Both taken with the same camera, right? The so-called polycam here. And I guess they took the same exposure time, so 4.2 milliseconds. So a very, very, very short exposure for both Jupiter and Bennu. And you know, when I first looked at this Jupiter image, I was surprised as to how similar it actually looks to, you know, images that I've taken of Jupiter through my scope. And yeah, it's you know, surprisingly similar.
So Bennu on the left and Jupiter on the right.
Correct. So here's the asteroid Bennu, which I guess, let's see, was about 2,300 miles away on October 22nd. So that was just a couple days ago. So yeah, they're coming up on it, right? I mean, 2,300 miles. That's not very far. It's not very far at all. That's
And
right
how much
next door.
exposure? 4.2 milliseconds?
4.2 milliseconds, right?
That's
so
short.
very, very short. But you know, they were probably limited a little bit because they wanted to get a good picture of Jupiter, right? And Jupiter's pretty bright. So yeah, you know, they chose a short exposure time, and what this shows, right, because it's the same exposure time, it does show, you know, that Bennu is much darker than Jupiter, but for a couple of reasons, right? One, well, let's see, yeah, also noticeable is a difference in the amount of light reflected by the two objects. So when these images were taken, Bennu was about 5 times closer to the sun than Jupiter was. So that's actually receiving 25 times more sunlight, right? Because it's a 1 over r squared.
It's a 1 over r squared. That's what's in a century risk table with the second highest luminance rating on the Primary Technical Impact Hazard Scale, Tonnenberg.
Yeah, I think, you know, I mean, I don't necessarily think that this has any. Okay, well, second highest rating. Interesting. Yeah, I mean, you know, the reason why, I think at least one of the reasons why they went after this asteroid was because it was relatively easy to get to, right? You don't need this huge delta V to get to it, because it does share such a close orbit with Earth. But yeah, you know, being that it does have that kind of orbit, it certainly is, you know, potentially a object that's going to smash into us at some point. But yeah, I just sort of thought it was really, really neat that, you know, even being 5 times closer to the sun, it's still much darker than Jupiter. And I think, yeah, they're actually saying here it's got a 3 or 4% albedo. So only 3 or 4% of the light that actually hits it is being reflected. Oh, here's a full image. Oh, it downloaded it. Because these are PNGs. They're all PNGs. All right. Well, here, I can do it this way. Open. I don't know how it's going to open it. Oh, there we go. Let's see. Maximize. Okay, so now we can sort of zoom in on it here and see. So, yeah, the last image of Bennu that I had seen was only a couple of pixels across. So this one is, let's see, how many? Maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, maybe 13 or 14 pixels across. And, it's also kind of obvious.
Would it have been different if you would have downloaded a lower resolution picture, or no?
No, I mean, pixels are pixels. And I think something looks like something's been done to these pixels. See how they're not really square? So it's kind of hard to tell what kind of processing has actually been done. But I'm going to sort of assume that we're actually seeing the pixelation of the camera, right? The polycam camera that's on the spacecraft. And so, yeah, I don't think that anything would really change. And since this is the highest resolution one, I sort of assume, that we are seeing pixelization here. But it's kind of neat. It sort of looks diamond-shaped, right? It doesn't necessarily look round. It's too hard to tell, right? I mean, at this point, but it definitely looks sort of diamond-shaped. And the interesting thing about that, right, is that the asteroid that the Hayabusa 2 spacecraft, the Japanese spacecraft, is at right now, asteroid Ryugu, also is sort of diamond shaped, right? It most definitely is not round. So yeah, kind of interesting if it maintains the shape. It's really hard to tell because of the pixelization here, right? It's really hard to tell.
What is the latest from that Japanese space jet on that asteroid?
I haven't really looked recently. Yeah, we should probably look at that again in the next couple of days.
And Tom and Scott, there's a 0.037% or 1 in 2,700 chance that Nebula will strike the Earth in the last quarter of the 22nd century. NASA scientists has calculated that.
1 in 2,700. That is not insignificant for sure. That's yeah. I mean, they what will improve? Well, what'll change those numbers is getting a better orbit. Hey there, Adam. Nice to see you. You're up very, very late.
At that time, we just never ever would know because we would pretty much be like as legends and stuff on the internet.
Yeah, well, regardless of whether it hits us or not, it would be really, really interesting to be alive when that thing passes by Earth, because regardless, that is going to be a very, very, very close pass, very close. So yeah, let's see, last quarter of the 22nd century. So that's something like 150 years from now. I'm going to have to change my plans if I'm going to see that. I'll have to think about that. But yeah, I mean that kind of an impact would sort of put a cap on things for sure, for sure. So yeah, it's a pretty big rock. Well, we're gonna have to find out exactly how big. I don't know what the size is here, but it's also interesting that there seems to be sort of a brighter feature over here. And it isn't really symmetrical either, right? It seems to be a little.
Now, my question is, if that asteroid ever does hit the Earth, what's the possibility we just might be wiped out?
I think that's a pretty good possibility that it would be pretty devastating. Yeah, we'll have to look and see how big this thing is, but I think it's a pretty big rock if I remember right. And here's, of course, Jupiter over here. Ooh, I wonder if that's a little moon. I don't know. Hard to tell. Kind of hard to tell. At
radius 800 degree or 800 feet, mass 78 billion kilogram, orbital period 438 days.
So an 800-foot radius, 800 feet. Okay. Yeah, we could. I'm going to check your. I'm going to check your work, Totterbert. Just because that's what good scientists do. Mu. Let's just do OSIRIS-REx. BENNU. BENNU. New. There it is. Let's see what the authority of Wikipedia says. Ha ha ha. Okay, so this is where you guys are getting all this info. Let's see. Observations of this minor planet by Spitzer in 2007 gave an effective diameter of 484 meters and an albedo of 4.
Tom actually can confirm the claim, and Adam Synergy OSIRIS-REx images will get a significant cover spacecraft approaches.
Oh, of course, yeah. I mean, these guys want to be able to see, like dirt, right? Because that's sort of, they're going, of course, to investigate this asteroid in terms of geology and in terms of all that. But the primary, I would call the primary mission of this OSIRIS-REx is to grab some of that dirt and bring it back, right? It's a sample return mission. So yeah, they're going to be able to see things really, really well. So, all right, well, at least what it's saying here is something like 484 meters, right? So that's, roughly half a kilometer in diameter. So that's a pretty good chunk. So, think about a rock, right? Hurtling through space at, several tens of kilometers per second, and smashing into the Earth at that speed. That's going to release a lot of energy. And what did they say in the chat here? 1.45 megatons. So, 1,450 megatons. So 1.45 billion tons of TNT. So yeah, that's a pretty serious amount. Um, and yeah, I'm looking forward to it for sure. You know, this is one of the cool things about being in astronomy. Like I was saying, is that you know there's almost always something new, and so here is sort of the newest thing, and we will see. We will see. It's it's a pretty exciting time. I'll bet the folks who are looking at this are just going crazy, right? Just absolutely insane because yeah. Now, I mean, this isn't the best image that we have of this yet, right? I mean, even the Wikipedia image here, which is a radar image, um, uh, looks better than what we're seeing already. But yeah, that's going to change really, really soon. And what I wanted to do was, and maybe we can do it here, maybe we can do it here. Let's just go here. We want to do this anyway. I just wanted to see when the encounter day is planned. Let's see. Overview. I guess overview might give us some ideas. And Bobby flashed out of the panel. Okay, got locked out of your computer. Don't be that guy who finds the planet killer. Yeah. Well, Todderbert, there are many objects out there. So far, we don't know, but I can say for certainty. Ah, Bobby's back.
Hey, thank goodness you checked the chat.
Check the chat. I did. So, but yeah, I mean, there are asteroids and comets and who knows what else out there that have our name on it, right? I mean, absolutely, 100%, for sure. We are going to get nailed by something big, and a whole bunch of small things too, right? I mean, we get nailed by literally tons of little things. Almost, I mean, all the time, right? I don't know how many tons of like space dirt and space dust fall on the Earth each year, but it's a very large amount, right? Very, very large amount. And of course, we don't know for sure because those are estimates. But yeah, what I wanted to do was I wanted to look and see when we're supposed to get our encounter. Cyrus-Rex fact sheet. Let's see if there's anything here. I just want to have a date.
December 3rd is the arrival at venue.
December 3rd? Oh, cool. Okay. All right. That's all I wanted to find out there. So, yeah, I mean, that's only a month and a half away. So, pretty awesome. Pretty awesome. They're getting really close. And yeah, I mean, look, I mean, it's only going to get better, right? I mean, this is pretty awesome, right? We've got a shape. We've got some, we've got a bright spot here, maybe a bright spot here. So, yeah, very, very cool. Very cool. It's probably rotating, right? I mean, all these things rotate. Everything rotates. So, yeah, very cool. Very, very cool. Yeah, so here's just all their instrumentation, right? They've got some cameras. Here's the sample or the sampler, right? They're gonna put this down onto the surface, right? This part here. Here, does this... it's going to load. It's trying to do it. Yeah. So they're going to put this thing down onto the surface, and it has some kind of mechanism, some kind of clever mechanism to sort of suck up a bunch of dirt, right? And then it's going to be carefully stowed somewhere in the spacecraft here. I forget exactly where. Whoop, this thing is frozen up on me here. It froze. All right, let's just go back. So yeah, it's going to stow that. I believe this is the part that is supposed to come back, right? This is the return capsule here, and so yeah, all this dirt will be stowed in here, and then what, in 2023, I think it said, it'll intersect Earth, and then we'll have our asteroid dirt. Yay! So very cool, very, very cool. Let's see, anything else? I don't know if there's anything else particularly interesting here. MapCam, Polycam, and SamCam. I think, yeah. Yeah, I'm not going to go through all of this. But yeah, it's on its way, and it's going to get there real soon. Real soon. So cool. I just like to see, these new images, and of course I like to share them too. So yeah, pretty interesting. Much darker than Jupiter for sure. It's a good measurement now, and yeah, we'll keep an eye on the shape too. That's you never know, but yeah, they're in the process now of looking around, right, and seeing if there are any moons or any other hazards, essentially hazards, because right, they're gonna put themselves right on the surface here, so they have to make sure, at least as well as they can, that they're not going to run into anything while they're moving in. That would probably not end well. So cheers. All right, let's see. So that's pretty exciting, for sure. I like it. I guess the other thing that we haven't done in a while is go over and look at the astronomy picture of the day. I'm sort of looking here to see when we last checked in, and wow, it was over a month ago. So we got all these new ones. Let's just sort of move through these a little bit and see what comes up here. Comet, cluster, and nebulae. Wow. Yeah, I think that's Jacobini Zinner, if I remember right. Yeah. Yeah, so this is in the constellation Auriga. And what have we got here? Yeah, M36 and M38. Let's see, which one is which? M38 is left, and M36 is on the right. So cool, yeah. Now M37 is, it's actually off the screen. It's way over here. But very cool. Let's, I always like to zoom in on these things if we can and look at the stars, see how round they are, see how the tracking was, how the focus is. Two Messier objects in the same Same field of view. Oh, I forgot that there was a cluster there too. Look at that. Cool. It's probably an NGC of some sort. I don't know what it is. So that's pretty nice. That's a pretty good shot. Nice nebulosity. What is it? Does it say anything about what wavelengths or anything like that? The comet was nearest perihelion and closest approach to Earth. Riga. Yeah, it doesn't say, at least in the little description here, what filters were used. I can only assume that a number of filters were used, but maybe this was used with the color camera. Yeah, it's hard to tell. Yeah, deep telephoto mosaic. Let's just see what that going to. I don't know if this will. He gives us a little bit more information here. 3-panel mosaic. So I'm not quite sure if this is a color camera or not. Let's see. Canon EOS 5D M2. Let's find out. Sort of looks like maybe it is. Mark II. Megapixel full frame, CMOS, DSLR. But is it color? That is the question.
I had to be crazy to use the digital camera for the job.
Oh, you know, these CMOS DSLRs are really getting pretty awesome. So yeah, I'm actually not surprised by that anymore. They're getting pretty good. Now, can these be used for science? I don't know. Color.
Did he also use a telescope as well?
Yeah, it looks like he did. It looks like he used a Vixen VSD 100 at f3, which is probably actually just a lens that he put on his camera, right? So technically, probably not a telescope, but you know, how do you define that, right? So, this is not saying if it's color or not. Full frame. Canon. Yeah, I'm not sure. If anybody knows in the chat, let me know. Yeah, because it's not really clear if this is a color camera or not. Don't know. I can only assume it is. But yeah, nice shot. Very nice. Let's sort of zoom in here a little bit. The stars are a little fuzzy, but oh, I'm not complaining. Not one bit. Yeah, that's a pretty good shot. Pretty good shot. And there's a couple of stars there, gotta say. Just a couple. Keep you busy for at least a couple days. You know, counting all those. Yeah, pretty amazing. We're in a pretty amazing universe, I gotta say. Nice comet. Very, very nice. can sort of maybe get an idea of two different tails here. You know, maybe sort of a dust tail going off this way and an ion tail going that way. Kind of cool. Nebulosity is nice. Yeah, good shot. Good shot.
But there was disclosure time on that.
You know, I think they mentioned it. I think it was like 150 minutes, 150 seconds. Let's find out. 150 minutes at a pretty high gain too. Pretty high gain. So yeah, that's a nice long exposure as you would sort of expect. Cool. All right, let's keep moving here. Ice halos. Yeah, okay. Meteor, Milky Way, solar filament erupts. Let's see what that. Oh, that's kind of nice. Wow. So this was taken with the SDO, the Solar Dynamics Observatory, towards the middle of 2012. There's this big, huge CME here, and yeah, they caught that pretty nice. Looks like, you know, they combined a few wavelengths, and then, you know, combined them into one image. But that's pretty cool. Gives you a nice sense of depth there. I think the Earth on this scale is maybe about as wide as that, I would say. So, you know, this is like an Earth-sized, maybe even larger, wide plume here, I guess you'd call it. Pretty nice. Okay, let's keep moving. Cosmic collision forges galactic ring. Yeah, it's a nice ring galaxy. Kind of funky colors on a few of these. Don't know what's going on there. Yeah, why don't we read the description here? Let's see. The rim of the blue galaxy pictured on the right is an immense ring-like structure, 150,000 light years in diameter. I'm being summoned again. Interior galaxy. Okay, that's probably what these are. These are probably the X-ray sources here. Let me. I need to perform another duty. So one moment, I will be right back. Enjoy the ring galaxy here. Hold on. Man, I'm sure earning my pay today. Gotta say. So yeah, I think these pink, purplish points are probably the X-ray sources, and then the rest of it is just the HST. So pretty cool. Pretty cool. You can see that right in the centers of these things are a lot of X-rays, but elsewhere also, right? Don't really know what's going on here, but yeah, you know, they're saying maybe at least a place where there are black holes or neutron stars or something like that. So cool. Lots of energy, right? X-rays have a lot of energy, and are usually, created with, some pretty um, um, energetic events. So pretty cool, though. Pretty cool. All right. Salt Pepper and Ice, Cocoon Nebula, Irregular Galaxy, NGC 55. Well, if it's irregular, I gotta look at it. Okay. Let's see, what does it say here? Regular galaxy is thought to be similar to the large Magellanic Cloud. Interesting. Just much more distant. Okay. Well, that's kind of interesting. I guess I never thought about the Large Magellanic Cloud being sort of disc-shaped. But they're sort of saying here that, or at least they're sort of implying that it sort of, might be. Yeah, cool. All right. Well, I mean, obviously, it isn't a nice symmetrical spiral galaxy or nice, egg-shaped elliptical. It's got some weird things going on, right? I mean, sort of the center of brightness. Here, we can zoom in on this a little bit. The center of brightness is here, and it's got one thing extending that far out, and this extending not quite so far out. So yeah, what's going on there? Don't know. A lot of gas and dust and whatnot also, and sort of nicely aligned in a disk, but kind of spread around a little bit too. So yeah, who knows? Hence the name irregular. It's not quite a spiral. It's not an elliptical. So cool. Okay. Equinox. Yeah, we like to see the position of the sun on particular days at a particular time, and you can sort of see that the sun works out this kind of figure 8 pattern. And this is it's I guess I'm a little confused about this. And the reason why I'm confused is because they've placed, and somebody correct me if I'm wrong here, but they've placed the sun at the what would be the northern hemisphere's winter solstice, right? I think equinox is when the sun is here, right? When these two things cross, that I believe is the position of the equinox. But they're calling this equinox, analemma over the Callanish stones. So am I completely sort of bonkers here or something? Am I missing something? Let's see if we can. Let's see. Does the sun return to the same spot on the sky every day at the same time? No. A more visual answer to that question is the analemma, a composite image taken from the same spot at the same time over the course of a year, every few days at noon. Okay. So Adam, have you ever seen the Callanish stones? I wasn't even aware of this. This is the first time I've heard of these. Anyway, it's not known. The ultimate cause is the analemma, is the tilt of the Earth, and its ellipticity of the sun's orbit around the sun. At the solstices, yeah, okay. At the solstices, the sun will appear at the top or the bottom. The equinoxes are in the middle. So I don't know. This is really weird, right? Because this is showing the sun at a solstice, not at an equinox, but they're calling this equinox. Yeah. That's sort of painful. It's a fantastic shot though. That's a nice shot. Really, really nice. But yeah, that's at a solstice. That's not at an equinox. So yeah. That's a little confusing. Okay, so here's, I think we've probably seen these. I think we looked at some pictures from actually Ryugu. Yeah, we saw these. Okay. So, well, I'm going to move on here. Highlights of the north, autumn sky, the sun's spectrum with its missing colors. Huh? Oh, okay, yeah. So there's a very, very high resolution spectrum of the sun. And the way that this is laid out is you sort of read this.
Added synergy, those stones are on Ornky Isles, I think. Not been there, but he likes to.
Yeah, cool. You always, of course, hear about Stonehenge, and that's all one actually hears about. Unless you're there, right? And then you'll know more about the local things. But yeah, that's kind of cool. I sort of like that one too. Let's see. Yeah, so I think you sort of read this left to right. So the bottom left here would be the most shortest wavelength, right? Shortest wavelength towards the ultraviolet, right? And that's why it's getting so dark, because we can't see in the ultraviolet. So, and then it sort of goes this way, right, all the way across, and then it picks up again in the next row, right, and then it picks up again in the next row. So yeah, we're seeing very, very high resolution spectroscopy here, and it's absolutely amazing, right? I mean, every single one of these little lines, right, represents some kind of absorption taking place on the sun, right? So that's some kind of atomic species that is absorbing that particular wavelength of light, and so obviously, we're not able to see it. And as you can see, some of these lines are faint, some of them are really dark, some of them are really wide, some of them are skinny.
Center, last time I was a stone circle, there were crazy naked people running around.
Cool. Well, I mean, that's what those are for, right? Yeah. Absolutely. That's not so crazy. But wow, this is a beautiful spectrum of the sun. And look how much stuff is there, right? Now, I mean, not every one of these lines is going to signify, like one atom, right? One kind of atom. Most atoms emit or absorb at many different wavelengths, tens or dozens or hundreds of wavelengths. Yeah, but and that's one of the jobs that the astronomers have to do, right? Is they have to sort all this out. It's like, okay, let's take this line right here, right? What element is that? Well, what you have to do is you have to go to the laboratory and you have to, you know, take an element and force it to emit or absorb light, and then take a spectrum and see what the wavelength actually is. And from that, you can get, you know, what atom is making this absorption line. But it's pretty incredible. That's a beautiful image, absolutely gorgeous. I think I'm going to save that as a as like a background. I think that's absolutely fantastic. I'll save it later. But yeah, incredibly complex. You know, the sun, just like everything else, right, is not simple. I mean, look at all this stuff down here. It's complicated. It is complicated. Double lines and yeah, wow. That's a great shot. That's a great shot. I like it. I like it. Very cool. Nigel Sharp. Actually, I know Nigel Sharp. Yeah. And 33, 55 nights with Saturn. I think I saw something like this. Oh, okay. That's kind of neat. So for 55 consecutive nights, Mediterranean skies were at least partly clear. That's pretty awesome, just in and of itself. From the 1st of July to the 24th of August. So an exposure from each night was you know, put into this composite image here, showing the motion of Saturn. Oh, what's that? Through the night sky. Now, oh, okay. So I'm trying to understand. I guess this, when you move over it, it shows the motion of Titan. Okay. Kind of interesting. Let's see if that'll... let's see what this does here. Okay, now it's just showing the motion of Saturn. But yeah, so there's the motion of Saturn over the course of 55 consecutive days. And as you can see, relative to us, right, it was slowing down, right? Every single day, it moved a little less. And yeah, pretty cool. You got to think a little bit about why its relative motion would be changing like that. Maybe I'll let you think about that for a while. That's pretty cool. Let's see, the lonely neutron star in supernova E010272.3. Lonely, huh? Why is this neutron star so off-center? Which one is it? Is it? I don't know. Recently, a lone neutron star has been found within the debris left over from an old supernova explosion. The lonely neutron star in question is the blue dot at the center of the red nebula. So this one right here, I guess they're saying, is a neutron star. So the displaced position of this neutron star is unexpected, since the dense star is thought to be the core of the star that exploded. Yeah, well, there's a lot of supernova remnants, I think, where the central neutron star isn't exactly in the center. And yeah, you can sort of wonder about why. I mean, maybe it's just a projection thing. Maybe it actually is in the physical center, but because of projection, right? I mean, we're looking at a three-dimensional object here on a flat surface. Well, at least as soon as it loads. So, I mean, it's possible that actually is in the physical center, but just because of, angles and projections and all that, maybe it just doesn't look as though it is. I don't know. It's an interesting picture, though, too. It's kind of weird colors. Kind of weird. Let's see. So it was taken... Okay, so blue is X-ray. Red and green are from the VLT and Hubble. Okay. So yeah, I mean, obviously there's an X-ray source here. X-ray, probably point source, right? Not really seeing much other blue other than, the nebulosity itself. So, yeah, I mean, you probably definitely have some kind of, high energy object there. So that probably is, but yeah, who knows? And well, they sort of make the implication here, that maybe it was part of a binary star system, and so it, got flung around. Hard to tell. Pretty good shot, though. Big diffraction spikes. But that's, typical of astronomical shots. The first rocket launch from Cape Canaveral? Oh, cool. The Bumper V2. That's pretty nice. Supernumerary rainbows over New Jersey. Cool. And you see 1898? Opportunity after the storm. I don't think they've heard from Opportunity yet, but yeah, there it is. It's sitting there. Don't think they're going to hear from it, but yeah, you never know. Scale of the Universe Interactive, Comet 12P. Okay, so this is, again, Giacobini-Zinner, I believe. Right? Yeah. Between the Rosette Nebula and the Cone Nebula. Yeah, here's the cone right here. Do you see that little thing here? We can probably zoom in on that. Yeah, so here's the Cone Nebula pointing downward, if you can see that. And of course, there's Giacobini-Zinner, and there's the Rosette. Pretty good shot, for sure. Little red. Yeah, maybe too much red. I don't know. I don't know much about those kinds of things. Good color of the comet, though. Nice. Pretty nice. All right. Well, there is so much. Let's look at one more. NGC 1672, a barred spiral galaxy. Huh, okay. I don't know. Come on. You can do it. I know you can. I know you can. I know you can. There it is. It's probably just really big, yeah. It's kind of interesting that they would call this a barred spiral galaxy. I mean, I guess, right? Maybe they're calling this a bar. I don't know. That's a great shot, though. Wow, look at these. Look at all these little stars in here. I wonder if those are actual stars or if those are... Yeah, it's got to be. Huh. We should look into this galaxy a little bit more. See what it's all about. Because, I don't think that we can see individual stars. We're probably seeing like star-forming regions. Because, I mean, individual stars are like this fuzz here, right? I mean, all this bright stuff here, those are stars. These little dots here have got to be something else. But I don't know if I've ever seen anything quite like that before. Huh.
Adam Sandler, Synergy, maybe Opportunity just sees a random encounter with a dust devil. Bring up the solar panels. Here's hoping.
Yeah, here's hoping. Here's hoping. That's that was actually one of the early concerns, right? When these two rovers landed, their panels were getting dustier and dustier and dustier. And everybody was sort of getting a little worried because it's like, they were getting, like measurable decreases in power. And it's like, well, what are we going to do here? And then all of a sudden, the batteries were charged and everything was great. And it's like, what happened, right? And the only thing they can think, and it's, I mean, I think this is reasonable, right? Is that some kind of, like a gust of wind or, maybe a dust devil came through and blew all the dust off. So, maybe that kind of thing can happen. I'm not quite sure, with these rovers, if the batteries like completely die, right? Like zero, right? At zero. Can they be recharged? I don't know. I don't know enough about them to be sure. But opportunity's probably gone, but I don't know what the big deal is, right? I mean, it was supposed to last for 90 days, and it lasted for like 14 years. So I don't understand why everybody is so sad and upset about that. I mean, I think it did great. It's great. And, if you want to do more like that, well, send another rover, right? I mean, don't be upset about, things that are finished. You have to, do a new one, right? What's the problem? It's just a little bit of this, right? That's all. All right. Well, I think it's getting a little bit late. It's 3:14 UTC, and Adam, are you going to bed or are you waking up? I'm not sure, but it is either really, really late over there or really, really early. So, but I'm really, really glad you joined us, and I'm glad everybody here did. But yeah, I think let's call it for today. Now, just as a reminder, starting a week from today, right? I'm going to have a live stream hiatus for, I think, at least 4 days, maybe 5. Yeah, I think it might be 5 days. Um, but I've pretty much decided that I am going to bring my smartphone, and if I have an opportunity to live stream from um, um, Laughlin, then I probably will. But it'll be at random times, right? I mean, I'm not going to be able to set any kind of a thing. I'm just going to start up a live stream, and we'll just go for I don't know how long. Just you know, basically just to say hi, and yeah, I think what I want to do is I'm going to look up the conference that I'm going to, because yeah, I'd like to show that off a little bit. It's a little um, I I'm not sure what to expect, but I guess these people are very, very serious, and they seem to think they know what they're talking about. Um, so we'll
Problem is temperature. When the heaters die, coal batteries don't charge, and maybe even some older systems won't boot.
Yeah, that's sort of what I was afraid of too. Yeah, cold batteries don't charge. Yeah, okay. So yeah, I mean, if it gets too dead, right? I mean, if it's cold, if the body's cold, you're done, right? So, but like I said, I mean, really, it's been going for 14 years, and we're upset about that. I'm not. I'm not. I think it's absolutely fantastic. I actually, I mean, I mean, I can't even imagine how much data that that is. We should go and look. Maybe I'll do that. I'm going to go and look and see what kind of data is there, and maybe I'll try to do some kind of artsy fartsy thing with it, and see how that goes. So, all right, well, cool. All right, I'm going to get out of here. Like I said, starting a week from today, there will be a live stream hiatus for like 4 or 5 days or so. Yeah, I'll be coming back then. So yeah, probably the first live stream after this that I will be doing will be for the 6th of November. So I think from the first, the second, the third, the fourth, and the 5th. So those 5 days, yeah, there will be no live stream. Although there will be maybe some random live streams, but I have no idea if or when, and they'll probably be short. It'll just sort of be a checking in, hi, I'm here, kind of thing. But yeah, like I said, I think I'm going to try to find out a little bit more about this conference that me and my musical partner are going to be performing at. We're going to be doing the um, opening ceremony, and then we're going to be sort of the background music at dinner. so so we'll see how that all goes. Should be fun. And like I said, this is sort of a unusual conference, so I don't want to say anything until I investigate it a little bit more. But yeah. All right. I'm going to get out of here for now, so I will see you all next time, which for me will be a little less than 23 hours from now. So take care, everybody. I will see you later. Bye.
Yeah.